always do it on my own, so I gotta get through it. And the only thing I know is to love what I'm doing. Never give up, never slow, till I finally prove it.
Objective: solves problem involving set with the use of Venn diagram. We will have a review of the previous lesson. Set A is a set whose elements are 1, 2, 3, and 6. Set B is a set whose elements are 2, 3, 5, and 7. We need to find A union B and A intersection B. So we have our answer. For A union B, the answer is 1, 2, 3, 5, 6, and 7. For A intersection B, the answer is 2 and 3. We need to find A union C and A intersection C. So for our answers, A union C, we have 1, 2, 3, 4, 6, and 8. For A intersection C, we have 2 and 6. We have another review. We need to find B union C and B intersection C. For B union C, we have 2, 3, 4, 5, 6, 7, and 8. Did you get it correct? Very good. How about the next one? So we have B intersection C. What element is common to set B and set C? The answer is 2. Did you get it correct again? Very good. So we have a Venn diagram. The English logician John Venn popularized the diagram in the 1880s. He called them Eulerian circles after the Swiss mathematician Leonhard Euler. We are now ready to make a Venn diagram. We have the set of universal set. We have set A and set B. So the first thing that we need to do is to find the common element of both set A and set B. What is the common element? The common element is 4. We are in set A. We have already 4. What are the missing elements? The missing elements are 2 and 6. Now we need to go to set B. We have 1, 4, and 5. We have already 4. What are the missing elements? We have 1 and 5. So we have already drawn the elements of set A and set B. Look at our universal set. We have 1, 2, 3, 4, 5, 6, and 7. We have the missing element for the universal set. And what are the missing elements? We have 3 and 7. This is how to make a Venn diagram. We have the given Venn diagram. This Venn diagram is the graph of A union B. We have another Venn diagram. This is the graph of A intersection B. So we have set A and set B, and we need to find A union B. First, we look at the common element of set A and set B. We have 3 and 2. For set A, we have already 2 and 3. What are the missing elements? We have 1 and 6. For set B, we have already 2 and 3. What are the missing elements? We have 5 and 7. So we have A union B equals 1, 2, 3, 5, 6, and 7. Since the Venn diagram is union, we need to color all the elements found in both set A and set B. So we have A union B equals 1, 2, 3, 5, 6, and 7. So we have our given using a Venn diagram. We have set A and set B, and we need to find A intersection B. So what are the elements common to both set A and set B? We have 3 and 2. What are the remaining elements for set A if we have already 2 and 3? So we have 1 and 6. How about for set B? We have 5 and 7. So we need to find A intersection B. What is A intersection B? That is the element common to both set A and set B. So the answer is 2, 3. We need to color 2 and 3, and that is A intersection B. We need to answer practice 1. Set A is a set whose elements are 1, 2, 3, and 6. And set C is a set whose elements are 2, 4, 6, and 8. We need to make a Venn diagram in A union C. Answer to practice 1. A union C means all the elements belonging to both set A and set C. Alright, and what is our answer? A union C equals 1, 2, 3, 4, 6, and 8. We have practice 2. We need to find A intersection C. We have the answer to practice 2. A intersection C means the element common to both set A and set C. So what are the common elements? We have 6 and 2. So we have A intersection C is a set whose elements are 2 and 6. We have practice 3. We have B intersection C means all the elements common to both set B and set C. We need to answer practice 3. We have B intersection C. So what is our answer? Our answer is a set whose element is only the number 2. We have practice 4. We need to find B union C. We have the answer to practice 4. We have B union C means all the elements belonging to both set B and set C. So we have B union C equals a set whose elements are 2, 3, 4, 5, 6, 7, and 8. So we have the Venn diagram for set A and A prime. We have set U, set A. We need to make a Venn diagram of set A. This is our Venn diagram for set A. Set A is a set whose elements are 1, 2, 3, and 6. We need to shade the whole circle. So we need to find A prime. What is A prime or complement of A? That is the element in U that is not in A. Ano ang nasa U na wala sa A? That is complement of A. We have the figure. So we have 1, 6, 3, and 2 for set A. And what are the elements in U that is not in A? We have 4, 5, and 7. And that is the complement of A. So we need to make a Venn diagram for set B. What is set B? 2, 3, 5, and 7. So we have U, whose elements are 1, 2, 3, 4, 5, 6, and 7. So we have the representation. We have set B, whose elements are 2, 3, 5, and 7, which is represented by the colored portion of the Venn diagram. We need to find B prime, or the complement of B. What is in U that is not in set B? So set B is a set whose elements are 2, 3, 5, and 7. Set U is a set whose elements are 1, 2, 3, 4, 5, 6, and 7. So we have the graph. So what are the elements in U that is not in set B? The answer is 1, 4, and 6. This is for A intersection B. And we have another one, A intersection B prime, or the complement of A intersection B. This is the graph of A intersection B, which is represented by 2 and 3. We need to find A intersection B prime, or the complement of A intersection B. So that is what is in U that is not in A intersection B. So we have the colored portion of the Venn diagram. Therefore, what is our answer? So A intersection B prime equals 1, 4, 5, 6, and 7. So we have the Venn diagram for A minus B. What is in A that is not in B? And the Venn diagram for B minus A. What is in B that is not in A? So we have set A, whose elements are 1, 2, 3, and 6. Set B, whose elements are 2, 3, 5, and 7. So we need to find A minus B. What is in A that is not in B? So what are the common elements of A and B? So we have 2 and 3. So what is in A that is not in B? And that is 1 and 6. So we have the given. We need to find B minus A. B minus A means what is in B that is not in A. So what is in B? So we have 2 and 3 as the common element. So what is in B that is not in A? The answer is 5 and 7. Alright, looking at the given set A, set B, and set C, we have already 3 circles, and the 3 circles are intersecting each other. What is the element that is common to both set A, set B, and set C? The answer is number 2. How about the common element of set A and set B aside from 2? We have the number 3. How about the common element of set A and set C? We have set A and set C. We have the number 6. Now, we'll proceed with set A. So we have already 2, 3, and 6. We have the remaining element. The answer is 1. For set B, we have already 2 and 3. What are the remaining elements? We have 5 and 7. And for set C, we have already 2 and 6. What are the missing elements? We have 4 and 8. This is how to graph using a Venn diagram with 3 circles, set A, set B, and set C. We are now in the problem solving. 50 students were asked if they have pet animals at home. 30 of the students have dogs and 32 have cats. Number 1, how many students have dog only? Number 2, how many of the students have cat only? So we need to answer the question. First, we need to add 30 plus 32. 30 plus 32 is 62. Since we have only 50 students, we have 62 minus 50 is 12. That 12, that is 12. That is the intersection of dog and cat. Next, we have 30 minus 12, that is 18. And we have the other one, 32 minus 12, that is 20. Now we can already answer the question, how many students have dog only? The answer is 18. The last question, how many students have cat only? The answer is 20. 30 students were asked about their favorite merienda. 19 of the students like spaghetti and 17 like pancit palabok. The question is, how many students like spaghetti only and how many students like pancit palabok only? First, we will add 17 plus 19 and that is 36. Since we have only 30 students, that is 36 minus 30, that is 6. So we have 6, we need to place 6 in the intersection of spaghetti and palabok. Then after that, we will subtract 6 from 19. 19 minus 6 is 13. Then we subtract 6 from 17. We have 17 minus 6 is 11. Now we can already answer the first question. How many students like spaghetti only? So we have 13 students like spaghetti only. And the next question, how many students like pancit palabok only? The answer is 11. 54 students were surveyed about their favorite subject. 35 students like math, 40 students like science, 34 students like English, 25 like math and science, 22 like science and English, 18 like math and English, and 10 like the 3 subject. So we are going to answer the following question. How many students like math only? How many students like science only? And how many students like English only? We'll start at the bottom. 10 like the 3 subject. So this is the intersection of the 3 subject. We'll put 10 here. Next, we have 18 like math and English. Math and English. What is missing 10 to make it 18? So we have 8. We have 22 like science and English. Science and English, 22. What is missing to 10 to make it 22? We have 12. 25 like math and science. 25 like math and science. If 25 like math and science, this is already 10. What is missing to 10 to make it 25? We have 15. Next, we have 35 students like math, 40 students like science, 34 students like English. So, look at this one. So, we have math. We'll start with math. We have 15 plus 10 is 25. 25 plus 8 is 33. And we have 35 minus 33, so we have 2. So we can proceed with the next. We have science. How do we get 3? 15 plus 10 is 25. 25 plus 12 is 37. We have 40 like science. This is already 37. 40 minus 37, the answer is 3. Next, we have English. For English, we have 34 like English. So, 8 plus 10 is 18. 18 plus 12 is 30. So, we have 34. 34 minus 30 is 4. So, now we can already answer the question. How many students like math only? Math only, the answer is 2. Next question. How many students like science only? Science only. The answer is 3. And how many students like English only? English only. The answer is 4. 25 students were surveyed about their favorite sports. 17 students like basketball, 13 students like volleyball, 50 students like tennis, 9 like basketball and volleyball, 8 like basketball and tennis, 6 like volleyball and tennis, and 2 like the 3 subjects. I have the question, how many students like basketball only? How many students like volleyball only? And how many students like tennis only? So we have 2 like the 3 subject. That is 2. 6 like volleyball and tennis. Volleyball and tennis, that is 6. What is missing to 2 to make it 6? We have 4. 8 like basketball and tennis. Basketball and tennis, that is 8. What is missing to 2 to make it 8? We have 6. 9 like basketball and volleyball. Basketball and volleyball, 9. We have already 2. What is missing to 2 to make it 9? We have 7. 15 like tennis. So we have 15 like tennis. 6 plus 4 is 10. 10 plus 2 is 12. 15 minus 12, we have 3. We have 14 like volleyball. So we have this one as volleyball. This must be 14. 7 plus 2 is 9. 9 plus 4 is 13. So we have 14 minus 13, that is 1. 17 like basketball. 7 plus 2 is 9. 9 plus 6 is 15. So, we have 17. What is the answer? The answer is 2. Now, we are ready to answer the question. How many like basketball only? We have 2. Then, how many like volleyball only? We have 1. And how many students like tennis only? The answer is 3. Thank you for watching.